Welcome back to another lesson on trigonometry. We still have a few more identities to derive before we can move forward. Lastly, we spoke about the angle sum identities. Let me summarize what we have so far.
Sine squared of theta plus cosine squared of theta is equal to 1. Along with that, we have 1 plus cotangent squared of theta is equal to cosecant squared of theta. And we have tangent squared of theta plus 1 is equal to secant squared of theta.
These are my three Pythagorean identities. Remember, we have
sine of negative theta is equal to negative sine theta. Cosine of negative theta is equal to cosine theta. Alright?
last time we derived the angle sum.
So sine of alpha plus beta equal to sine alpha cosine beta plus cosine alpha sine beta. Then we have cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta.
Let's see what happens if I did sine alpha minus beta. Well, that's going to be sine alpha cosine of negative beta. Cosine of negative beta is going to be the same as cosine beta, so that stays the same. Now we're going to have cosine alpha is the same, but sine of negative beta. Sine of negative beta is going to be a negative sine beta, so this changes from a plus to a minus. So that's a quick teaser of how we can use the other identities to derive more. Same thing with cosine of alpha minus beta. Cosine remains positive, so that's going to be the same. Cosine alpha cosine beta. Now, sine alpha sine beta. Alpha is positive, so that's sine alpha. Now, sine of negative beta is going to be negative sine beta. So the negative sign here changes to a plus. Pythagorean identities, even odd identities, and angle sum, angle difference identities. Let's see what else we can do. If I pick this one, such that sine of 2 theta, that's the same as sine of theta plus theta. So what's that going to be? Sine theta cosine theta plus cosine theta sine theta. Well, the order of multiplication doesn't matter. Sine, then cosine, or vice versa. So this is simply 2 sine of theta cosine theta. Likewise, cosine of 2 theta, that's the same as cosine of theta plus theta, which is equal to cosine theta times cosine theta is cosine squared theta minus, well, sine times sine is sine squared theta. So these are what we call double angle identities. I will put them here for summary.
Sine of 2 theta is equal to 2 sine theta cosine theta. And cosine 2 theta is equal to cosine squared theta minus sine squared theta.
What else can we do? Notice the similarity between this and the Pythagorean identity. Let's see if we can do something there. Cosine squared theta minus sine squared theta is equal to cosine 2 theta. That's going to be cosine squared theta plus sine squared theta is equal to 1. So if I add these two, cosine squared plus another cosine squared is 2 cosine squared theta. Now a negative and a positive is going to cancel out, so that's 0. And that's equal to 1 plus cosine 2 theta. All right, we're almost there. Divide both sides by 2, and I get cosine squared theta is equal to 1 plus cosine 2 theta divided by 2. All right, so this is sometimes called the half-angle identity. We could replace theta by an arbitrary symbol. Let's just say alpha over 2 is equal to 1 plus cosine. Well, what is 2 times alpha over 2? That's simply alpha. So this angle is half of that one, hence the term half-angle identity.
Cosine squared theta is equal to 1 plus cosine 2 theta divided by 2.
Now, can we do something similar with sine? The answer is yes. So I'm going to flip the order of these. Cosine squared theta plus sine squared theta is equal to 1, and cosine squared theta minus sine squared theta is equal to cosine 2 theta. Now if I subtract instead of add, well, cosine squared minus cosine squared is 0. Sine squared minus a negative sine squared is going to be 2 sine squared. Is equal to what? 1 minus cosine 2 theta. All right, again, I can divide both sides by 2, and I have a half-angle identity for sine.
Sine squared theta is equal to 1 minus cosine 2 theta divided by 2.
Great. Notice the similarities and the subtle differences. Positive and negative signs, for example. Now, let's rewind a couple lessons to compare a result there with a result we're about to find. Remember what we said? Sine of pi minus theta. It's 180 degrees minus theta. Well, we can use our angle difference identity to say this is equal to sine of pi times the cosine of theta minus cosine of pi sine of theta. Well, sine of pi from the unit circle is 0. Cosine of pi is this is a negative 1. So negative times a negative means this is equal to a positive sine of theta. So go back to that video and check it out. You'll see that it matches up. What about cosine of pi minus theta? Well, again, we'll plug it into our angle difference formula. It's going to equal cosine of pi cosine of theta plus sine pi sine theta. Well, again, sine pi is 0, so that term drops out. Cosine of pi is a negative 1, so this is equal to negative cosine of theta, which indeed matches up what we found in that first video. What about sine of pi over 2 minus theta? Same thing. Sine of pi over 2 cosine of theta minus cosine pi over 2 sine theta. Go back to your unit circle. Cosine of pi over 2 is 0. Sine of pi over 2 is a positive 1. So this is simply equal to cosine theta, 1 times cosine. And this becomes a positive 1. Same thing. Cosine pi over 2 minus theta is equal to cosine pi over 2 cosine theta plus sine pi over 2 sine theta. Again, unit circle tells us cosine of pi over 2 is 0, so this term drops off. Sine of pi over 2, well again, unit circle tells us that is a positive 1, so that leaves us with sine theta. Okay, it's good to know that the identities we derive are consistent with our intuition from the first lesson and what we decided from that. In summary, These are some basic identities, so make sure you're familiar with them. Sometimes it takes a few go-arounds to become comfortable, especially when it comes to deriving them. So go back through and review this as much as you need to practice to get familiar with it. We will find application for these in future lessons, so stay tuned for those. Thanks for watching.